And welcome back. As we go ahead and continue looking at file I/O, we're now going to go ahead and look at this with the buffer reader class instead of the scanner class for reading in a text file. So what is the buffered reader class? Well, until the scanner class was introduced in version 5.0 of Java, the class buffer reader was the preferred stream for use of reading it from a text file. In fact, it's sometimes still used as a class for reading from a text file. Now, the class buffer reader, much like our classes print writer and scanner, has no constructor that takes a file name as its argument. So we need to use another class, in this case, the class file reader, to convert that file name to an object that can be used as an argument for buffered reader. So if we want to open a text file for the buffered reader class, it's going to be a pretty simple line of code that's going to be familiar for what we've seen. We have a buffered reader input stream equals new buffer reader, new file reader, and here I have an example, more stuff.txt, or more stuff 2, I should say. And you can see it has that same structure that we're kind of familiar with. We have our class name, the name of our object, new, and then of course buffered reader here instead of like scanner, for example, equals a new file reader. So here's our file reader in those parentheses. Now, after this statement, of course, we can use the methods such as readLine and read in order to read data in from that file. Now, when used in this way, the file reader constructor and hence the buffer reader constructor invocation can throw a file not found exception, which, as we know from our previous experience, is a type of I/O exception. Let's look first at that readLine method. Well, an object of the class buffer reader that's connected to a text file, such as we're going to see here later in the text file input demo, has a method named readLine that is much like our method nextLine from the scanner class. Now note there's actually only two methods for reading from a text file, and that is readLine and read. So let's take a look at that read method. Since we said readLine works pretty much very similar to nextLine, it would be logical to assume that read looks just like next. However, the read method is only reading in a single character, which we would expect if we think about this with our next method. But instead of returning a character, as we might expect, it's actually going to return a value of type int that corresponds to whatever character has been read in. It does not necessarily correlate to the character itself. So that means you can't read in like A, B, C, etc. It's going to be looking for a 0 through 9 numeric value. Thus, in order, let's say if we want a character value, we instead have to typecast, such as in char next equals char input stream dot read. Very important distinction here because, again, when we think about this with the scanner class, next line is a string and next is effectively still a string. But here with the buffered reader, next line is a string, but next is going to attempt to put it as an integer. So if we want to have it as something else, we have to typecast it. Now, if input stream, of course, is in our class buffer reader and is connected to a text file, this is going to set the next value that we pass in equal to the first character in the file that has not yet been read. Now, we already mentioned some exceptions here. All right, any program that has a buffered reader will need to catch two kinds of exceptions, the file not found and I/O exception, much as how we've seen with other file inputs. Any attempt to open a file, of course, can throw a file not found exception. Any invocations of inputstream.readLine can throw that I/O exception. Now, because file not found exception is a type I/O exception, you could use just the I/O exception to handle all that. However, as we have talked about previously, if we do this, we get less information if that exception is thrown. If you only use one catch block and the exception is thrown, you'll not know if the problem occurred either when you open the file or when you attempted to read the information from that file. So again, that's why we help differentiate this out into these two different types of exceptions. Now here's a quick tip for you. Reading numbers with the buffered reader class. Unlike our scanner class, the class buffer reader has no methods to read a number from a text file. All right, we have to write our code to read that number effectively as a string and convert the string to a value of a numeric type, such as int or double. So if we want to read a single number on a line, and notice it's using more of the read line method and not necessarily the read, we want to read it using a method, read line as I just mentioned, and so then we have to use integer.parseInt or double.parseInt or some other similar method to convert whatever's in that string to a number. So if there are multiple numbers, for example, on a single line, we have to read the line using readLine and then use the string tokenizer class to actually decompose that string into tokens. So we have to actually break it apart into smaller substrings. Then, of course, we would use like integer to parse int or a similar method to convert each token into a number. And again, this is only if you're using the read line. If you're using read, remember that is automatically an integer type, which works. But what if we had a double type? And this is, of course, when we might want to use read line over read. Now, in closing here, let's just real quickly talk about the buffered reader versus the scanner. Why we might want to use one class over another, because they have, in this case, very similar functions. Well, the buffer reader is synchronized, or what's known as thread safe, while the scanner class is not. Additionally, one of the strengths of the scanner class is that, well, it can parse primitive types and strings using regular expressions. We, have a read int, we have a read double, we have, or excuse me, a next int, next double. We can do all those that the buffered reader class cannot. Buffer reader also allows you to change the size of the buffer, so the allocation of memory, while the scanner class actually has a fixed buffer size. And the buffer reader, by default, actually has a larger buffer size for dealing with things that you're trying to pass through. Scanner also hides I/O exception, while the buffer reader actually forces us to handle it. You have to have that exception set up in your buffered reader class. And buffer reader also has the advantage of being faster than the scanner class because it's only reading the data in without parsing it. So it's not going to try and figure out, okay, is this an integer? Is this a double? It handles all that and just like, hey, I got this data. What do you want me to do with it? And here's our text file input demo over in Eclipse. And you can see here, I have a quick demonstration of how this class is going to be used. We have our input stream set up right here. And I wanted to leave this one in here as an error just to show you when you try to use input stream.read, and made a little note here, it needs to be an int because you look, I have string a letter and I have it set to input stream.read. And so if I change this to an int, you'll see, of course, it updates that where it's no longer complaining about that. And we look at more stuff.txt, we're starting here with a number. But if I were to put, let's say, an A in here, okay, so if I change that to an A and I try to read it in, so let's just go ahead and read that. You'll see we get the first line from the file is, and we get just nothing here, all right, because it's trying to read in here something that is not viable. So let's just see if we typecast this. Let's go ahead and put a char typecast here. And we'll change this to char a letter. All right. And of course, we now get, helps though if I put what is that output stream here. So let's add in a system out of print line. And we'll just put a letter in here, because others, it's not going to do any good to actually print that out. And so we run that one more time. So here's our A now. And we still get the first line is now blank, because remember, it did not return that. So we actually would have to add in here a input stream dot, and we want to actually just simply do a read line here, just a blank read line. And we're not going to store that because, again, we want to move that carriage return down. And then if we rerun that, we now get 1, 2, 3, and the second line is jack jump over. And that, of course, is a real quick and easy use of the buffered reader class. Again, the biggest thing to keep in mind here is that the read line method is always going to pull in a full line of code, whereas the read method here is only going to pull in a single value. So again, I'm going to show this real quick. If I take this char cast off here, let's take this one off, and let's put this back as an int. And if I try to run this again, you'll see it now shows back as 97. And you notice 97 is not A, because what it's actually doing here is it's actually printing out the Unicode value that's probably associated with that. So if I, for example, change this to an uppercase A, save it, and rerun it, you'll see I now get 65. If I were to make this something like, let's say, what looks like a number, let's just say 5, and I run it, you now see we get 53. So again, it's corresponding to the Unicode value here. So even though it is storing it as an int, it's not necessarily pulling in what we want to be as an int. So let's just say if I typecast this one more time, all right, and then I rerun this, again, you see it still puts back as 53. So this is something you have to keep in mind here when you are, of course, trying to work with some of these values, because what you might expect may not be. And notice here it says the integer part int is not applicable because in this case, this is still pulling that in as a integer. So this is not the way we typically want to handle our inputs, is with this. So I'm just actually going to take this right out. So I'll actually take out that read line too. And so when we deal with these, if I actually want to get the numerical values here of, let's say, 1, 2, 3, remember we'd have to parse this out here. And then I could, of course, take from this line I have here and actually put that in as a integer value. So if I had int, let's just say next num, and I have that input stream, or I already inputted that stream, so I actually have that stored here into lines, so I can take and do a integer, and I want to parse the int of line. If I try doing this right now, you'll see we get a number format exception, because if you remember, line is going to read in this whole line of code here. And so that's why we said we have to make sure when we do this, we have to tokenize this. So there'd be a little bit more work that I have to do here to actually make sure that when I pull this in, I'm actually getting the actual token of this. Because if I just try to pull this in as a whole string, again, you can see we get an error. And that's something I'm going to leave you with to see if you want to try and troubleshoot that on your own. But that gives us a little bit of idea of one of the shortcomings, if you will, of the buffered reader class, that if we're used to working things with the scanner class, that we'll have to address.